Okay, let's have another work example on SRW 411 sieve analysis. This question is a past question on the year 2021-2022. Okay, so you can put the question down. Assume 3/8, 4, 8, 14, 28, 48, and 100 mesh sieve were used for sieve analysis of ground materials. And these tables shows the percent of the materials by weight retained. If x minus y is equals to 9.87, okay, this is the table that we are given in the question. I've already drew the table out, okay. This is the table that we are given. This is the table of the result that we are given in the question. Now, they told us that x minus y, let me just jot it down, x minus y is equals to 9.87. You understand? So the first question says find the value of x and y. Find the value of x and y. Okay. The second question, calculate the fineness modulus. And the third question, calculate the average of the material in the ground. Okay, let's start with the first question. We are told to find the value of x and y. That's the first question. We are told to find the value of x and y. Okay, now let's start. Don't forget that we are given that the mesh in each are these. These are the sieve that we use in the analysis. Okay, the size of opening of each sieve is this, Abi, and the third row is the percentage of material retained. And if you look at the rows to which the percentage of material retained, we can see that we have the value of x and we have the value of y. Now, when we talk about percentage tells us the fraction, percentage is the expression of anything, any number as a fraction of 100. You understand? So when any numbers is expressed as a fraction of 100, you can say that we have taken the percentage of that number. You understand? So, and when we talk about percentage means 100. Percent means 100. Percentage is sum up to 100. That's it. Okay? So now, in an attempt to get the value of x and y, we have been given an equation, which is what the difference between x and y is what 9.87. Now, in order to calculate the value of x and y, I'm going to first sum up all these values to 100%. You understand? Don't forget, the reason why I'm going to sum all these values to 100% is because when we talk about percent is sum up to what 100%, because all these value we have taken the fraction of 100. You understand? So in order to get the value of x and y, I'm going to sum all these to 100%. So let's proceed. So I'm going to have 0.07 plus 5.84 plus x, you understand, plus 34.86 plus 38.48 plus y plus 3.75 plus 2.17, sorry, 2.17 is equals to what? 100. You understand? So now let's add 0.07 plus 5.84. If you sum all that together, you're going to get x plus y plus, now add all the numbers together using your calculator. You're going to get 85.17. So 85 plus 85. Is it 85? No. Okay, it's 85. 85.17. Don't forget your percent is equals to what? 100%. You understand? So let's proceed. X plus y is equals to, if you collect like times, x plus y is equals to 100 minus 85.17%. Oh, sorry. And you can put percent. Is important, percent. Okay. So x plus y is equals to 100% minus 85.17%. That is 14.83. 14.83%. You understand? So the sum of x and y is what? 14.83%. Now we have to determine the value of x and y separately. You understand? This is the sum and this is their difference. You understand? So now, to determine the value of x and y, we have to solve the equation simultaneously. You understand? We have to solve the equation simultaneously. So if you didn't understand simultaneous equation, I want you to pay attention here. Now let us write out our equation. Let's start with the first equation that we are given in the question. We are given that x minus y is equals to 9.87. So let me start. X minus y is equals to 9.87. We are going to call this equation 1, okay? I pay attention, okay? Now, from the one that we got from the percent of material retained, so I'm going to have x plus y is equals to what? 14.83. There is no need of putting percentage because we want to use this to solve. We want to use this to solve. We want to solve this simultaneously. You understand? So there is no need of putting percentage here. So call this equation 2. Okay. Now I want you to pay attention here. You can see that we're going to solve this equation, simultaneous equation, using the elimination method. You know, there are various methods of solving simultaneous equation. There is substitution method, graphical method, you know, and elimination method. But I'm going to use elimination method to solve this because it is very, very easy using elimination method. You can see that we have different sign at the front of y in equation 1 and at the front of y in equation 2. So if I add this together, I'm going to eliminate y. You understand? Elimination method of solving simultaneous equation deals with elimination a variable, elimination one unknown to get another unknown. You understand? So in order to eliminate y, I'm going to add this equation together. As you can see that the coefficient of y in equation 1 is what? -1. The coefficient of y in equation 2 is what? +1. So if I add this equation, I can easily eliminate y. So I'm going to add both equations. If you add both equation 1 and 2, we are going to have 2x minus y plus y. That is what? 0. You understand? So we have already eliminated y. So now 9.87 plus 14.83. 9.87 plus 14.83. That is 24.70. 24.70. So in order to get x, I'm going to divide both sides by what? 2. You understand? In order to get x, I'm going to divide both sides by 2. So I'm going to have x is equals to 24.70 divided by 2. So what's the value of x? X will be what? Punch your calculator, you're going to get, that is 12.35. So x is what? 12.35. So we have gotten the value of x, but we are not only told to find the value of x, but we are told to find the value of x and y. So in order to get the value of x and y, I've gotten the value of x. The next thing is that I'm going to substitute x into any of these equations. So let's make use of equation. Let's substitute x into equation 1 and equation 2. You understand? So I have x plus y. Equation 2 is what? X plus y. X plus y is equals to 14.83. 14.83. So the value of x that I got here is what? 12.35. So I'm going to have 12.35 plus y is equals to what? 14.83. So from this, I'm going to what? Collect like terms. You understand? So if I collect like terms, I'm going to have 14.83 minus 12.35. So let us subtract that. 14.83 minus 12.35, that is 2.48. So for this, I'm going to have 2.48. So the value of y is 2.48. The value of y, so let me write it here. The value of y is 2.48, and the value of x is what? 12.35. So for this, the value of x is 12.35. So we are done with the first question, which is calculate the value of x and y. Now the next question says we should calculate the fineness modulus of the materials. Now, how do we determine the fineness modulus of this material? Don't forget that fineness modulus can be expressed mathematically as sum of fraction retained by weight, sum of fraction retained by weight all over 100. Do you understand? So this is the formula for calculating the fineness modulus. I represent it as what? Fm, fineness modulus, is equals to sum of fraction retained by weight all over 100%. We are going to create a table to get the sum of fraction retained by weight, you understand? But please, if you didn't understand what is meant by fineness modulus, there is a link in the description of this video. Click on that link to watch the full video on fineness modulus, including sieve analysis as a whole. That video provides an explanatory on sieve analysis, fineness modulus, and all other concepts on this course. Okay, let's proceed. So this is the table that I constructed to calculate the sum of fraction retained by weight. The first column in this table stands for the mesh. You understand? This is the mesh. I just put all the mesh here. As you can see, 3 over 8 is here. 4, 8, 14, 28, 48, 100, and pound. As you can see, this is the mesh. This is the column of the mesh. And I have the size of opening. You understand? The size of opening are here also. So I just put this I just put all this in the respective cells. You understand? So for the percent of material, I've not completed that one. So that I just want to explain to you that I've not done anything. What I have here is all I have here. You understand? Only that I change this to column form. You understand? They are in rows. You understand? So I change it to column. You understand? So for this 12.35, this will be 34.86. This will be 38.48. This is 2.48. You understand? And this is 3.75. 3.75. And for the last one, I have 2.17. So I've already written the percentage of material retained in this column also. So now I'm going to have my multiplying factor in this column. Multiplying factor. Okay, multiplying factor. You understand? This column stands for multiplying factor, and the multiplying factor of pan starts from 0. You understand? The multiplying factor of mesh after the pan is 1. You understand? The multiplying factor after for the next one will be 2. The multiplying factor for the next one will be 3. This will be 4. This will be 5. This will be 6. This will be 7. Now I want you to note something. You understand? The multiplying factor for pan will always be what? 0. You understand? The multiplying factor for pan will always be 0. And the multiplying factor for mesh after the pan, which is the 100 mesh in this place, that will be what? 1. So after you number 0 as the multiplying factor of pan, just know that you are going to the next mesh after the next mesh after the pan will be take the multiplying factor of 1. You understand? So I want to note that, okay? Because peradventure you might not be given 100 as the last mesh. You might be given like maybe another mesh, maybe like 200. You understand? So just know that after the pan will take a multiplying factor of 0. Then the next mesh will be what? 1. Then you proceed up to the numbers of mesh that you have. You understand? So if you have another mesh after 3 over 8, you put 8. You understand? So, but I'm having 3 over 8 as the last mesh. That's why I stop at what? 7. You understand? So now, in order to get the sum of fraction retained by weight, I'm going to multiply the multiplying factor by the percentage of material retained. Do you understand? The multiplying factor for let me just put it, the sum of fraction. Let me just put it, sorry. This one should be fraction retained by weight. I've not summed everything up. Fraction, this will be fraction retained by weight. Okay, this should be fraction retained by weight. When I sum it up, that is what we call sum of fraction retained by weight. But ordinarily this column stands for fraction retained by weight. Okay, so to get the value of these cells, I'm going to multiply 7 by 0.07. Do you understand? Let me take my calculator here. Okay, so to get the value of these cells, I'm going to multiply the percentage of material retained multiplied by the multiplying factor. You understand? So to get the value of these cells, I'm going to multiply 0.07 by 7. That will be 0.49. So 0.49. So for these cells, I'm going to multiply percentage of material retained, which is 5.84 by 6. Do you understand? Just take the percentage of material retained of these cells and multiply it with the multiplying factor. You're going to get the values that is here, okay? So 5.84 multiplied by 6, that is 35.04. 35.04, you understand? So for these cells, I'm going to multiply 12.35 by 5. That is 61.75. 61.75. Okay? So for these cells, that will be 34.86 by 4. That is 139.44. Okay? For these cells, I'm going to multiply 38.48 by 3. That is 115.44. 115.44. Okay? So for the next cells, I'm going to multiply 2.48 by 2. You understand? So 2.48 multiplied by 2, that is 4.96. 4.96. And for these cells, 3.75 by 1, that is also 3.75. And for pan, that is 2.17 multiplied by 0, that is what? 0. Do you understand? So I have gotten the fraction retained by weight. Now the next step is that I'm going to calculate the sum of fraction retained by weight. To get the sum of fraction retained by weight, you have to sum up the fraction retained by weight. You understand? The summation of the fraction retained by weight is what we call the sum of fraction retained by weight. Do you understand? So let's proceed to sum all this up. So when I add all this together, I got 360.87. You understand? So this is 360.87. That is the sum of fraction retained by weight. So we can easily calculate the fineness modulus using this formula. The fineness modulus is equals to the sum of fraction retained by weight, and the sum of fraction retained by weight is what? 360.87. So I'm going to have 360.87 all over 100. Do you understand? So the fineness modulus is equals to, if you divide this by 100, you're going to get 3.6087, which is approximately is equals to 3.61. Do you understand? So we have calculated the fineness modulus. Now, to determine the average size of materials in this grant, we are going to make use of these formulas. The average size of, okay, let me just put it number 3. That is represented as the average. You understand? The average size of ground material is equals to 0.0041 multiplied by 2 raised to the power of the fineness modulus that we got. This is the formula that we are going to use to calculate the average size of materials in the ground. Do you understand? So the only thing that we're going to do is that we're going to plug in our fineness modulus. You understand? We have already been given that we have already calculated the fineness modulus as 3.6. Okay, I'm going to make use of the unapproximated figure. Do you understand? You know, I've already approximated this. So I'm going to make use of this. Do you understand? So the average size of ground material is 0.0041 raised to the power of 3.6087. Please, do you understand how I got here? This is the formula for calculating the average size of ground material. That's why I told you that you should always watch the crash course of this video. On this course. Watch the video, the lesson that I made on this course, you understand? So that you're going to understand all this. So let's proceed. The next step is that 2 raised to the power of 3.6087. If you punch that in your calculator, you are going to get 12.1991. So this will be what? 0.0041 multiplied by 12.1991. You understand? So the average size of ground material is equals to 0.0041 multiplied by 12.9991. No, sorry, 12.1991. That is 0.05 this is 0.0500. You can, just leave your answer like this, okay? So the average size of ground material is 0.05. So we've been able to calculate all the questions that we are asked to calculate from the past question, okay? So now, in order to understand what is the importance of finite modulus and the average, I'm still referring you back to that links. Kindly hit the links in the description of this video to watch the crash course. Thank you. See you in the next class. See the needs to subscribe to this channel. Kindly hit the subscribe button if you have not done so.